Chalo, no problem. You just go through them, and in case you have any time, any query or anything, you can just call me or text me also on WhatsApp. I will respond. Whatever
Okay.
we have done so far, if you run through the summary sheets, you will see all the words, key sentences, everything is included into that. Okay,
Yes.
so more or less it covers 100% of whatever we have done so far. Okay, so yesterday we did about the fixed wing operations and aerodynamics, and then we have done the rotorcraft operations and aerodynamics. These are the key topics, and now the last part of it is hybrid operations and aerodynamics. So when we talked about the hybrid drone, or which is also called as VTOL, okay, so VTOL is nothing but the combination of the aeroplane and the rotorcraft
Helicopter.
drone. Okay,
Rotorcraft, right?
rotorcraft drone. So let's see what does it. So let's see what are the principles of aerodynamics, types of hybrid drones and parts, and application of hybrid UAVs. Okay, where these hybrid UAVs comes into the usage, so that the development of the hybrid drones. And then I would say that especially in the supply or medical supply, these hybrid drones are very much used because of their capability of vertical takeoff and landing.
Landing.
Whereas if you see from the perspective of principles of aerodynamics, when it is in flight, it's basically flying like an aeroplane only. Okay, so whatever the aerodynamics is applicable to the normal aeroplane, be it manned or unmanned, the same principles will apply here also.
Okay.
Okay? So principles of aerodynamics for hybrid: the lift, weight, thrust, and drag. The four forces acting on the drone. So as we know, the lift is being generated because of the difference in the pressure. So airflow changes and the pressure differences over the airfoil will cause the lift. Weight is basically the weight of the drone, whatever the weight it has, and the gravity will effect on it, and it will try to pull the drone back to the ground. Okay, whereas thrust is generated by two components. One is the vertical rotors, which actually helps initially to take off the plane from the particular position, and once it's in the air and it is in a forward direction, it does a transition. It transitions from a rotorcraft to the aeroplane. So there would be a fifth motor, which could be a puller motor or a pusher motor, depending upon the position of the motor. Either the motor could be at the backside of the fuselage, or it could be on the front, on the tip of the aeroplane. So based on the position of the motor, it could be the puller or pusher. So that's how your thrust would be done.
Okay.
Drag is there. Drag will be always there. Only what we can is reduced by designing the entire hybrid drone aerodynamically. But we can't reduce drag to zero. So there will be a drag because there will be a friction, or what we call it as a
Resistance.
surface area resistance will
Yeah.
actually cause the drag. So these are the four forces acting on a drone, which will help to see. I mean, we can just plan or design the drone in a such a way that we get maximum lift and maximum thrust. Okay, weight is only what we can control based on the components and the payload what we require. Drag we can
Okay.
manage with the shape of the drone, the way we design. Okay, so as we have seen the airfoil in the principles of the flight, it's the curvature structure or the cross section of the wing, which has a leading edge and the trailing edge. The straight line from the leading edge to the trailing edge is called chord line, whereas a line from again leading edge to trailing edge with equidistance from upper surface and the lower surface. Okay, if you see the yellow line has equidistance from upper surface and the lower surface, that is called as a mean camber line. Okay, this camber line is there.
Okay.
Okay, and the distance between the leading edge and the trailing edge is called chord. Okay, this chord is very important. As we have seen, it helps to understand the angle of attack. So again, the terminology: leading edge is the part of the aerofoil that hits the air particle first. Trailing edge is the part of the aerofoil that hits the air particle last.
Last.
Chord line is a straight line joining the leading edge and the trailing edge of the airfoil. Chord is the distance between leading and the trailing edge measured along the chord line. Okay, then we have seen lower surface, upper surface, mean camber line. Maximum camber line is the maximum distance between the mean camber line from the chord line. I mean, see, what is this? The distance. Okay, wherever there is a maximum distance, that is called a maximum distance. As you see, gradually at the tail or at the start, it will always be less. So wherever there is a difference between the camber line and the chord line, that is called as a maximum uh, camber. Okay, or maximum thickness also it is being called. Okay.
Okay.
So again, what are the forces acting on the hybrid drone? So when we are talking about hybrid drone, the similar to the aircraft, lift is the force that holds the drone in the air. The wing creates most of the lift used by the airplanes. Weight is the force caused by the gravity. Thrust is the force that moves an aircraft in a direction of the motion. It is created with a propeller, jet engine, or rocket. Okay, it could be whatever it tries to push forward. That is that whatever that mechanism we use could be the thrust it will generate. So air is pulled in and then pushed out in a opposite direction. One example is like household fan. Drag is the force that acts opposite to the direction of the motion. Always we should understand drag is always in opposite direction of the motion. It tends to slow an object. Drag is caused by the friction and difference in the air pressure. Okay. An example is putting your hand out of moving car. Yesterday we have seen this example, right? Putting
Yeah.
out the hand in a car window, you can feel that it is getting pulled based on your angle of your palm. So if you put your palm parallel to the ground, it may just glide, or it may you will not feel that pressure. But as you turn 90-degree, you can feel that your hand is going back or pulled back,
Yeah.
kind of thing, right? So that's how the drag is experienced. Okay, another example. I mean, see, basically, your principle of Bernoulli principle is the most important principle on which the aeroplane flies. Okay, or aeroplane, goes into the air.
Yes.
So if you're able to understand and think from this perspective, then you will able to design the aeroplane in such a way that it can always fly. Okay, so again, top
Okay.
of the airfoil is shaped to provide longer path than the bottom air molecule. So that's why you see, if there is a slats, okay, if there is a slats here, it will increase the length. If you have in front also, there will be some. So those extra what do we call that, you know uh, surface area which
Yeah.
increases. Okay, those counters will actually increase the size. Okay, so top of the airfoil is shaped to provide longer path than the bottom. So as you increase the shape of the wing, it will generate more surface area, and that will actually create a difference in the pressure. Okay, as the difference in the pressure is created, it will produce lift. So when the aeroplane is flying, they will extend the flaps, they will extend the the surface area of the wing, so that maximum lift can be produced. But when they are actually landing, because that is the time when they want to reduce, okay, so they want to reduce that difference, so they will create something called as a drag. So they will have a spoilers. Spoilers is nothing but there will be a some similar type of flaps, but they will go in opposite direction. So somewhere here on the wing itself there will be, so whenever the airflow is flowing, it will not smoothly flow and meet there, so it will be break. So the flow will be something like this upside. Okay, it will go up.
Got
Okay,
it.
so that's the spoilers, and that's actually reduces the speed of the aeroplane when it is landed on the ground. Okay, now let's see the parts of the hybrid drones. As I said earlier, the structure is similar to the aeroplane. Okay, if you see, structure is completely like aeroplane. The fuselage, the wing with ailerons. Then you have a horizontal stabilizer where we have elevators. Then you have vertical stabilizers where we will have radar like structure. Okay, for a vertical tent. Then you have four rotors, which are actually motors which helps the hybrid drone to take off and land on the ground from the same position. Okay, it doesn't require a runway or anything. Whereas if you see, there is, for this particular hybrid drone, there is a motor behind the fuselage, so it is called as a pusher motor. If the same motor would have been in front of the nose, it would be called as a puller motor. Okay, so depending
Okay.
upon position, they are designed this thing. So basically, it is basically to make sure the motor or it has been positioned in such a way that the weight is balanced. Okay, if you put a probably a motor in front, probably it could be more heavier in the front, or maybe so based on, because if you see backside there is nothing, like it doesn't have a extended fuselage structure kind of thing. If it had a
Yeah.
extended fuselage structure up to the tail, they would have put the motor in further. But if you see here, there is no weight itself. Okay, so just to balance out the weight, probably they would have put a pusher motor behind,
Understood.
and then probably they would they might be having a camera below the belly. Okay, so
Hmm.
just to avoid any obstructions, it might be a forward front camera kind of thing, so it want to take a photograph. So normally you see in hybrid drones there will be a camera or any payload would be there in the front. So just to avoid any obstructions, they normally put the motor behind, the pusher motor or the flying motor or the thrust motor, what we called it also, that might be put it in the backside.
Okay.
Okay, so this is the different configuration of hybrid drones. So if you see from a vertical takeoff, see there are some drones, hybrid drones are designed where the same motor are being utilized for the forward motions also. So if you see here, the motors are in vertical position. So this will help the drone to go into the air, okay, or take off. Okay, once it is take off, then there is something called transition maneuvers. So the angle of the motor will keep on changing. Okay, so as it is moving in a forward direction, it will just change the angle and it will become horizontal here, so which will help to move forward. So once it is forward, it is doing its mission or project, it will do, and then again it will do the transition maneuver. That means your horizontal motors will become again vertical. So once they are in a vertical position, then it will do the vertical landing. So that is how actually some drones are also designed the same motor to be utilized for both purposes. Sometimes once it is in a flight forward flight portion, maybe the back motor also stops, so it is only just flying on the two motors. Okay,
Okay.
that's how you consume less battery, or how you utilize the battery very less, and that's why you will get more endurance in hybrid drones. Okay, so there are different types of hybrid drones. Like you can see here, again, these five motors with hybrid drones with five motors, or there could be a two motors where it is actually changing the angle of the motor. So when it is in a forward flight, it will be in a horizontal direction. When it is in landing or takeoff position, the motors would be in vertical positions. Whereas if you see, this is one of the best hybrid drone so far. I mean, this is been used very extensively in surveys and all that things. So this orange color drone, what you see is Wingtra hybrid drone. Okay, so it has only two motors. Okay, so it actually lands on its tail like this when it is landing or takeoff. Okay, so it is always in this position. When it goes in the air, it transitions by the control
Okay.
surfaces. Okay, the control surfaces will transition it in a such a way that it flies like an aeroplane. Okay, so actually I am involved with one of the company in Rajasthan also. I mean, it's a startup where actually they are trying to design. I mean, we are designing the similar type of a drone for Indian government, one of the projects where they wanted to do the survey using this type of a drone.
Okay.
Okay, so actually, we had more or less the design is almost similar. Only minor changes we are doing by the shape, especially the landing section. What we wanted to make sure that it is much stable and is able to land. The side sticks are basically we have put a hydraulic. Okay, small hydraulic sticks we have put so that it can adjust on its own based on, because all four corners may not have a very plain surface kind of thing if there is up and down. So we don't want the drone to be tilted or maybe something like so. The side sticks are basically which can change its length, okay, based on the terrain part. So that is what we are trying to incorporate, and the testing will probably progress somewhere in mid of April kind.
Okay.
So this is one of the stable, like you can search on the net also, Vintra, and you will able to see a lot of videos are there, lot of so I mean, this is older version V1, I think. Now they have come with the new version called V2.
Wingcraft V1.
Vintra.
Wingcraft V1.
Vintra V1, yeah, V2.
Okay.
Okay. V2 is the latest one where they have incorporated the LiDAR also into their payload.
Okay.
Okay, so what are the applications of the hybrid VTOL? Hybrid VTOL is used in operation where terrain is difficult to land. A fixed wing airplane means, for a fixed wing airplane definitely we need a runway or kind of thing, but endurance needed is more than the multi-rotor. So there could be a location like especially terrain, where we have up and downs and all the things. So in that scenario, hybrid VTOL is, wherever we have a difficult terrain, but we can't fly the multi-rotor also because of the less endurance. In that scenario, the hybrid VTOLs comes into a help. Okay, so it is used in the large area mapping. It is used for transport heavy payloads over a large distance with hilly terrain. Okay, it can also help for search and rescue and cargo delivery. So that's what I was saying. Hybrid VTOLs are very much useful for supply as well as medical deliveries. Okay, where the cargo or the payload is very heavy, and again it has to be delivered at a very difficult what we say terrain kind of thing. Okay, large
Okay.
distance with a hilly terrain. In that scenario, most of the time people are using hybrid VTOLs. Okay, so cargo delivery search and rescues, as well as used for large area mapping, very complex, very large area where you want to, so that you have a more endurance and all. In that scenario, you will use hybrid
So
vehicle.
that means the drone taxi kind of a thing will be a VTOL model, right?
Yes. So even
If at all it comes in
drone
the
taxi is
future.
also a VTOL model. So where you can carry 2 or 4 passengers, and it can take off from a particular vertiport. What we call it is a vertiport. From vertiport, it will take off, go to the destination. Again at destination, there will be another vertiport. So wherever these drones land, like how we have in a helicopter, we call it as a helipad. Similarly, for the drone, it is called as a vertiport. Okay, so vertiports,
Vertiport.
you have to create a vertiport 4 by 4, depending upon the size. Basic size, what is been government has decided, is that 4 by 4, meters, 4 meter by 4 meter kind of area you need to designate, and you have to build. It needs to be little bit elevated. If it is on ground, then you need a more clearance apart from 4 by 4 meter area also. So
Okay.
if it is on the top of the building or wherever you have elevated space and all the things specifically for the landing of the drone, then that vertiport has to be elevated with 4 by 4 meter dimensions. Okay, so that's the quick overview about the hybrid drone
Hybrid operation.
operations and aerodynamics. So any questions you have so far? I mean,
No,
we
sir.
will
I'm.
mostly cover the fixed wing rotorcraft and hybrid drones.
Yeah.
Okay.
So I had gone through this in the notes that you have given. So
Mhm.
most of it is clear.
Right. So with this, we actually complete our day one topics.
Yeah.
Okay. So we'll start with our day.